Welcome to the session on probability, Venn diagrams. The objectives for this session are to draw and interpret Venn diagrams. It is possible to use a Venn diagram to represent events graphically. Probabilities or frequencies can be inserted in the regions of the Venn diagram. So, some of the notation we use is S is the sample space, and closed curves in the sample space represent events. So here's the sample space S, and we've got two closed curves. Generally we use circles, and these are representing two events here. Event A and B is this shaded region here. The intersection of A and B is denoted by A intersect B, with an upside down U denoting the intersection. Event A or B denotes this shaded region here. This is the union of A and B, and it's denoted by A union B, where the union is denoted by a U. Event not A, or the complement of A, is denoted by this shaded region here. And in terms of probabilities, we have that probability of not A equals 1 minus the probability of A. Let's now have a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1A first. In a class of 25 students, 6 are in the football team, 4 are in the tennis team, and 2 are in both the football and the tennis team. A student is chosen at random from the class. Draw a Venn diagram to represent this information. So let's solve this. We begin with the sample space S, as shown, and two circles. One represents the football team, and one represents the tennis team. Two students are in both the football and the tennis team, so we put the number 2 in the center, or in the intersection area. 4 are in the tennis team, so we already have a 2 in there, so we put 2 in the tennis circle which doesn't intersect the football circle, as shown. And 6 students are in the football team, so as we already have a 2 in the football area, we put a 4 in the other area which does not intersect with the tennis area. So we have 6 altogether in this circle. And of course we know that there are 25 students, so because we have 8 altogether in the football and tennis circles, that means there are 17 left over, which go in the sample space but don't go in the football or tennis circles. And now for part B. We are required to find the probability that the student is not in the tennis team. So the probability that the student is not in the tennis team is 21, which is 17 plus 4, as shown, out of 25. And now for part C, find the probability that the student is not in the football or tennis team. This is, of course, 17 out of 25. And now for example 2. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. In a survey of 100 people, it is found that 35 own rabbits, 39 own cats, 47 own fish, 3 own rabbits, cats and fish, 13 own rabbits and cats, 16 own rabbits and fish, and 5 own fish and cats. We're going to draw a Venn diagram of this. So we begin right at the center. We've got our sample space. We have a circle representing ownership of the rabbits, a circle representing ownership of the cats, and a circle representing ownership of the fish. And we should always start in the center because these numbers are then accounted for as we expand. So the shaded area represents the area where people own rabbits, cats and fish. And of course, 3 people own rabbits, cats and fish as highlighted in red. So the probability is 3 out of 100 or 0.03 because there are 100 people. And now for the rabbits and cats intersection. The probability that somebody owns rabbits and cats is 13 out of 100, which is 0.13. So the missing probability is 0.13 minus 0.03, which is 0.10. And so that goes in the shaded region there as shown in red. And now for the rabbits and fish intersection, we have that 16 people own rabbits and fish. So the probability is 16 out of 100, which is 0.16, and the missing probability is 0.16 minus 0.03, which is 0.13, and that goes in the shaded area as shown. And now for the fish and cats intersection area, the probability that somebody owns a fish and a cat is 5 out of 100, which is 0.05. The missing probability is 0.05 minus 0.03, which is 0.02, and that goes here as shown. And now for the fish section, we have that 47 people own fish. The probability is 47 out of 100, which is 0.47. And the missing probability is 0.47 minus all the other probabilities in this circle, which has been shaded. So minus 0.03 plus 0.13 plus 0.02 as shown, to give 0.29. And we put the missing probability here as shown. And now for the cats section, that's been shaded. 39 people own cats. The probability of owning a cat is therefore 39 out of 100, which is 0.39. Again, the missing probability is 0.39 minus all the other probabilities added together which are in that circle, and that gives us 0.24. So we plug that in as shown in the shaded area. And for the rabbits, we have that 35 people own rabbits. So the probability that somebody owns a rabbit is 35 out of 100, which is 0.35. and therefore the missing probability in the shaded region is 0.35 minus all these other probabilities in the shaded region, which is 0.09. And we plug that in as shown. And notice that we have 100 people altogether. So is there a missing probability? Let's check. We need to do 1 minus all the probabilities in the shaded region added together as shown. And this gives us 0.10, which of course means that there are some people in this survey who don't own pets. And that probability goes here, as shown in red. And now for example 2a. A person is chosen at random. Find the probability that the person owns only rabbits. Clearly, somebody owning only rabbits is in this shaded region here, so the probability is 0.09. And now for part B. A person is chosen at random. Find the probability that the person does not own cats. A person not owning cats is represented by this shaded region here. We add up all the probabilities in this shaded region, so 0.09 plus 0.13 plus 0.29 plus 0.10 to give 0.61. And for part C, a person is chosen at random. Find the probability that the person does not own rabbits, cats, or fish. And a person not owning any rabbits, cats, or fish is in this shaded region here, and of course the probability here is 0.10. This brings us to the end of this session. If you have understood its contents, you should be able to draw and interpret Venn diagrams. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.